Now, we're also going to talk about some tips. Joe mentioned some tips and techniques for machining. These apply to plastic injection mold. So from here out, as far as the demo portion, we're primarily going to be talking about plastic injection molding, but we're going to just show you some parts as well for the other two. So if we start up on the left, we have, it's called dial in your accuracy. Now, obviously, for injection molding inserts, the accuracy is very great. You'll be dialing in this accuracy. The precision is very high on these inserts, especially in the parting line area near your cavity and your parting plane and your parting surface. And we're going to show you how to dial in that accuracy. From there, we'll go down to the cutting tools. We're going to talk a little bit about as a generic rule, which types of tools are better to use than others. And then over here on the bottom right, we see what we call in protection surfaces. So we're going to show you how to add protection surfaces to your inserts in order to protect them while you're machining them. And then up on the top right, we're going to show you what I'm calling the first contact rule. And I'll get into that in more detail. But basically from the illustration, you get the gist of the rule. And we'll go into that in more detail in just a moment. Oh, let me go back one. Okay. Dialing in your accuracy. We have 6 areas in RhinoCAM that you want to check and adjust depending on the accuracy requirements of your customer. And typically you will start in the arc fitting tolerance. Obviously, if you're fitting arcs on your cavity, you want that to be your final highest resolution accuracy. And from there, we'll back off and do the CAM operational global tolerance, and I'm going to go through these and show you in the part. But typically, you want to do your arc fitting tolerance. In our example, we're starting with 1/1000th, and then the CAM global tolerance is half of the arc fitting tolerance, so that would be 1/1000th. And then we're going to look at setting the CAD Geometry Tolerance. So we're adding 2 more decimal places to that, just for rounding. And then we're going to look at how to adjust the CAM part sampling resolution. This is a setting in the CAM preferences which affects your accuracy of your machining. Also, we're just going to touch base on the tool just to make sure that you have all of the decimal places filled out on your tool. If you need a 3H tool, don't enter 3.37, okay? You want to use all the decimal places you need to fully define that tool diameter. And then lastly, but not leastly, before you post, you want to go into your post processor and make sure that you have the correct number of decimal places being posted. If you do all of them, 1, 2, 3, 4, and 5, but you don't adjust the output in your post, it's all for naught because you won't see it in the output coordinates. Again, any questions? Everyone holler, okay? Okay, the next tip or technique is for the cutting tool. Basically, what we're trying to get across here is that you want the stoutest cutting tool that you can use, the largest diameter, the largest shaft diameter, which will, and the shortest length of the tool, which will create a very strong tool. It'll eliminate any deflection in the tool, and that's what you want. And then, and on this tool, we show a taper. Obviously, if you have a part that needs draft and your part doesn't have the draft, then obviously you're going to want to use a taper tool in order to machine that draft automatically. So on the right, we see a no-no. We see a long, narrow tool, small diameter, a lot of deflection going on in that tool, especially if you're machining hard materials, sometimes you'll have to come back and do revisions after that. Those inserts have already been heat treated. So very strong steel that you're going to have to cut. So you want to stay away from very long tools, which can affect your resolution and tolerance. Now, the third technique we're going to show you is the protection surfaces. And by protection surfaces, in our example insert, you see that we have added extensions to the cavity surfaces, and we have added extensions to the parting surface of the mold. So here on the parting surface, you see that it extends out past the mold on each side. And these are really, they're not complex to create, and I'm going to show you how to create them in Rhino. And Rhino is the best product to use for, in my opinion, to use for injection molding, especially for the surface modeling that you're going to need. So on the right, we see the cavity extensions and how they're extending up past the parting line. And as the description testifies, these surfaces are playing interference with your parting line. It's protecting it from the tool. So we don't want the tool to beat up on the parting line. You don't want it to run over the parting line. You don't want it to roll over the parting line. And you don't want it to roll along the parting line. You want a nice clean cut across that parting line. And we're going to show you how to achieve that. Now, in our example part, we did do, ahead of time, I did the roughing and re-roughing of this part. And just as a note, in the re-roughing, that is a Pro configuration toolpath. In the Pro and Advanced 3-axis, you get a whole range of toolpath methods that can use exclusively for mold making. And we're going to go over those a little bit later. So the final technique I guess we're going to get across is what I'm calling the first contact rule for machining parting lines, cavities, and parting surfaces. If you consider yourself the tool and you're running along this parting surface and you hit that parting line, the first contact rule states that you will not touch that same point on that parting line again in the same operation. So that tool will just say, howdy parting line, I'm going on my way. It's touched it and it's continuing to cut in other areas. It doesn't stop on the parting line. Like I mentioned, it doesn't roll over the parting line, and it doesn't roll along the parting line. And that's what these protection surfaces are used for. So they're going to show you, basically I'm telling you how to do it, but we're going to show you the end result of using this technique and not using this technique. And it's very stark comparison. Now, we see here after using the first contact rule and not using the first contact rule. So on the left, we have the cavity machined out and we have the parting surface machined out. On the right top, you will see the cavity, cut material simulation of the cavity, the entire insert with the first contact rule implemented. So you see a nice, clear parting line, very distinct. There's no colors bleeding from one side to another. And if you go in the middle image, you'll see that. You'll see areas where the cavity is bleeding over into the parting surface and vice versa. This area, you're allowing the tool to literally beat up on the parting line, and that's going to cause flash. Not so much mismatch because of your accuracy, but you're going to get flash, and you know, you're going to see this in your prototypes when they come out of your inserts. Out of your cavity inserts, and you're just going to be throwing this cavity in the trash bin because it's not any good. And here's just a close-up of the one contact rule on the right, nice and clean, very precise, no bleeding from one side to another. versus on the left. And this is literally how your insert's going to come out. I mean, you're going to be machining up on your parting surface when you're supposed to be machining your cavity, and vice versa. And there's nothing you can do about this if you don't use these protection surfaces. And I'll show you that as well. Joe, is there any questions? If you have any questions.
No, you're doing fine, Don.
Okay.
There's some comments, but
Okay.
there's a lot of experts seem like to be watching today, so they know what they're doing. So
okay,
continue,
great.
please.
Okay, so there's our first contact rule up close. Now, we have published some documents and articles relating to mold insert machining, parting line machining. I'm going to put, when we send you to the webinar replay, I'm going to put links in there that where you can get to these articles and read them for reference.